Okay, so welcome back. So what we're going to do today is we're going to put it all together. We're going to do some examples of where you're doing more than one transformation to graph a function. So let's look at these three examples. So the first one is an absolute value, uses an absolute value function in there. The second one also uses an absolute value function. And the third one is going to use a quadratic, so a squaring function. So we're going to graph these using transformations. So look at how I do these, because these are the way that I'm going to expect you guys to do it on a quiz or an exam if I ask you to graph something using transformations, okay? You've got to show me that you're using the transformations to get to this function, starting with a parent function, or in other words, one of the basic functions, okay? So let's start with the first one, and we'll plot the absolute value function first, the basic function. Okay, so I'm going to graph the basic function of absolute value of x. So let's do this. Okay, so alright, so there's our basic function. I'll call it, excuse me, let's call it g of x. Now I want to use the transformations that's being used here to get this to be this graph. Okay, so the first thing I notice is there's a negative sign in here, right? So what does the negative sign do to the function? It's outside, so I'm multiplying the absolute value. So this is, let's just do this. So basically the first thing is I'm multiplying the absolute value function by -1, right? So what does that do? I'm multiplying the y's by -1, which means it's going to reflect across the x-axis. So what I'm going to do is, now I'm going to use a different color to show this. So I'm going to flip it down. So now the resulting function is going to be this. And so now this is the first transformation, right? Okay, so this would be y equals negative absolute value of x. Now what am I going to do? Well, let's go inside here. What's going on inside? I'm adding 3 units to x, which means this is what kind of transformation? This is a translation. So is it up or down? Well, in this case, I'm inside the function. I'm inside the absolute value function. So this is going to be a horizontal translation. And so is it left or is it right? Well, I'm adding 3, which means x would have to be -3 to be 0. So that means I'm moving 3 units to the left. So now this red, this is moving 3 units to the left. So 0 is going to -3. So that's going to go there. This point is moving over 3, so that's going to go here. This point is moving over 3, so that's going to go here. And then so on. This is going to move over 3, so that's going to here. And this one is moving over 3, so that's going to be right there. So now, that's what I get. So now this is y equals negative absolute value of x plus 3. And now finally, the last translation is this +1. So I'm outside the absolute value function. So that means I'm affecting the y values. So that means I'm going up or down. And since I'm adding 1, that means I'm going to go up 1. And so the final function we get is now we're going to go up 1. So now we're going to move this up to here. Like that. And so this is going to go like this. And so our final function is this one right here. So this is f of x equal to the negative of the absolute value of x plus 3 plus 1. And that's how we use transformation. So I used our basic absolute value function and used the 3 transformations that was going on. I reflected down across the x-axis, and then I moved to the left 3 units and moved up 1 unit. Now, could I have done it in a different order? Yes. I could have translated this up 1 to the left and then reflected it across the y equals 1 here, but if you're going to do the reflection, it's almost sometimes easier just to do it across the x-axis when you at the beginning, because it's easier to plot, and then do the transformations. But again, if you keep things straight, you'll get there regardless of the order that you do your transformations in. Okay, so that's that one. So there's A. So let's do this one here. Okay, so now let's look at h of x. Now the first thing I'm going to do is, when you want to look at these things, you want to see if there's a way to simplify these. Because here, I'm multiplying x on the inside of the function by 2. Okay, so remember, what kind of transformation is that? Okay, if I'm multiplying by x by 2, a is bigger than 1. So that means this is going to be a horizontal compression or a horizontal shrinking. Okay, but then I'm subtracting 2, or excuse me, I'm subtracting 4, which means I'm moving to the what? I'm moving to the left 4 units, it looks like. Or not to the left, to the right. I'm moving 4 units to the right. But it's a little misleading to do it that way, okay? Because I've got a common factor here, okay? So if I write this differently, so let me write this a little differently. Like that. So now, what's going on here? So in this case here, you can see that, hey, this is actually a horizontal shift to the right 2 units. Okay, because you've got a common factor here. So it's a shift 2 units to the right, and then you're multiplying by 2, so that means it's a horizontal shrinking. Okay, since A is bigger than 1. Okay? So now, let's start with our absolute value function again. So let me sketch the graph. Okay, so here's our f of x equal to the absolute value of x. And so now, what's the first thing we're going to do? Well, here's what I'm going to do. You can multiply all the x values by 2. Okay? So you can multiply everything by 2. But here's another thing. Look what we could do. I can rewrite this as the absolute value of 2 times the absolute value of x minus 2, so this is actually 2 times the quantity x minus 2. So what's actually happening here, now I can do it this way, so I can go ahead and multiply each value of x by 2 and then see what we get for the answer. right? So I could still do it this way, but it's easier if you just pull it out and then use the fact that the absolute value of 2 is 2. And now it becomes a what? A horizontal, or excuse me, a vertical stretch, which does the same thing. But it's easier to work with. So now if I do x minus 2, right? So I'm going to move everything to the right 2 units. So that means 0 moves to 2, and this moves over 2 to 3, 1. Let me do it this way. And then this moves over to 2, so it moves there. Okay, and so this becomes that. I'm a little off, but like that. Okay, now this is the translation. So this is going to be, let's call it g of x equal to absolute value of x minus 2. Okay. Now the last thing I'm going to do is I'm going to multiply all of the y values by 2. So I'm going to double all the y values. So what's that going to do? Well, my final answer is now 0 times 2 is 0, so that's going to stay there. But here, what do I got? My y value here is 1. So 1 times 2 is 2. So this one's going to move up to the 2. Okay. This one's going to move up to 2. And then this one was at 2, so this will move up to 4. And then, of course, this one's going to move up to 4. And so now I get this. And so this turns out to be our final answer. This is the final graph. So h of x equal to the absolute value of 2x minus 4. Now, so notice again, I moved to the right 2 units, and then I multiplied by 2. And I could have done it the other way around. I could have just multiplied here by 2 and then did the horizontal translation. Okay, but again, as long as you're showing how you get there. Okay? And then the final one is a quadratic. So again, let's do the simple quadratic, the basic quadratic. So there's our quadratic, our x squared. So this represents y equals x squared, right? So now, what are we doing with g of x? Well, we're multiplying the function x squared by -1/2. Okay? So there's 3 things going on here. We're multiplying by negative, which means it's going to be a reflection, right? It's going to be a reflection across the x, in this case it's going to be a reflection across the x-axis. And then we're also multiplying by a, which is in this case less than 1. And then we're also adding 4 outside the function. So this is going to be a vertical translation. It's going to move up 4 units. So again, let's see how we're going to do this. So I'm going to do the reflection first. Right? So that's going to be the easier one, I think, to do. So let's reflect. So that means this is going to stay there. The 1, 1 is going to reflect down to 1, -1. And the -1, 1 is going to reflect down to -1, -1. And then this is going to reflect down to 4. Likewise for this one here. Okay, and like that, like that. Okay, so that's the first one. And now what I'm going to do is I'm going to take half of these y values. So that means this one is going to go down to -1/2. right? I'm cutting everything in half. And this is going to go down to negative in half. This 4 is going to go down to 2. And this is going to go down to 2. Right, let me just make sure. Okay, and so what's happening is now it's going to look like this. So now, again, because this is less than 1 and I'm outside the function, it's a vertical shrinking. So I'm pressing down on it. So it's getting wider. And now the last thing I'm going to do is now I'm going to translate it up 4 units. So now my final answer is going to be, this is going to move up to 4. So that's going to move there. This half is going to move up 4 units. So this is going to become a half, 1.5, 2.5, 3.5. So this is going to come right about here. And then this one here is going to come up about right here. Okay, and then this one here, this is at 2, so 2 is going to go to 2 here. And then of course we'll have this one over here at 2. And so we get, oops. Something looks like that. And so this is the final graph. So this is g of x equals negative 1/2 x squared plus 4. Okay, and that's it. That's how you use transformations to graph a given function, starting with the basic function or parent function. And that's it. Again, practice these. There are going to be some of these on the exam or quiz, so you got to practice these. If you have questions, please make sure you ask. Get some help. Okay, if you have any questions or need help, please reach out and practice these. Okay, that's it. Have a great day.